want to solve, want to answer the question on differential calculus, differentiation, all that came out in the Utme 2011 questions. We are going to consider paper type D of that year. Now, in that 2011, that's 2011, we have 3 questions on differentiation. And on paper type D, this question came in number 36, number 37, and number 38. The first question is a product function. The second is a trig function, while the third is an application of differentiation, which is in the area of maxima and minima. Now, the first question is the derivative of 2x into 3x plus 1. So that means y is equal to 2x plus 1 into 3x plus 1. We want to differentiate this, and that is very simple if we know what to do. Of course, what we have to do here as JAM candidates who is subject to limited time is to expand. We expand the bracket. We have 2x times 3x, that's 6x squared, plus 2x, then 1 times 3x, that's 3x, 1 times 1, that is 1. So we have y is equal to 6x squared plus 5x plus 1. Now, we just use rule of differentiation of power function and constant function to get our final answer. So the y, the x, therefore, will be, to differentiate this time, these two will come forward and multiply this 6. That gives us 12. Then the x squared becomes x raised to the power 1 because we say 2 minus 1. That's the basic rule of our derivative, right? Then when we differentiate 5x, we have 5, right? Because this one here will come forward and multiply 5, and that gives us 5. Now the new power will be 1 minus 1, which is 0. And we know that when we raise anything to power 0, that gives us 1. So that means x becomes 1. So we have 5 times 1, which is 5. Differentiating 1 is what? 0. So the y dx is 12x plus 5. That's it. So that is option D for number 36. Option D. We actually apply the method which is when we have y equals to ax raised to the power n, then the y dx will become the power n will come and multiply a, that is n times a, then x raised to the power n minus 1. This simple logic is the original power will multiply the function. Then we'll now subtract 1 from the original power to have a new power for the derivative. So that is the method. That's why 6x squared becomes 12x power 1. The 2 come forward and multiply 6, that's 12x. Now subtract 1 from this power 2, that becomes 1. Alright, this one is having power of 1. Initially this 5x is having power of 1. Then we use that 1 to multiply this 5, we get 5. Then x having a power of 1 initially. When we subtract 1 from that 1, that becomes 0. And when we raise anything to power 0 from indices, that term becomes 1. So that x turns to 1, so 5 times 1 is what? 5. Differentiation of a constant is 0. So that's how we arrive at 12x plus 1. The second question in 2011 on differentiation is a trig function. And we're going to look at that right now and see how we can use shortcut method to solve that quickly. Now, number 37, 2011, it goes this way. Obtain the derivative of sine theta over cos theta. Alright, a good math student have to understand that sine theta over cos theta is tan theta. And then from the knowledge of derivative, we know that dy dx, that's derivative of tan theta, is sec square theta. Simple. So that is the answer to that question, and that is option A on paper type D, 2011 mathematics. Now, we have to understand that derivative, that sine theta, derivative of sine theta over cos theta is the derivative of tan theta, and derivative of tan theta is sec squared theta. Now, in summary, I have to give you the basic trig derivative. We have y as sine theta, differentiating that will give us cos theta, and then when we have y as cos theta, differentiating that will give us minus sine theta. The same way, when we have y is equal to tan theta, then derivative of that will give us sec square theta. Sorry, not dy dx, actually dy d theta. We're differentiating with respect to theta. Dy d theta will be sec square theta. So that this is the summary of differentiation of trigonometric ratios. Alright, thank you very much. We'll continue the solution to number 38 of the same year after this short break.